When we're developing a piece of code, we're usually focused on just getting it to work, especially if it's something complicated. Often, that means trying different approaches and testing until we figure out what's going to get the job done. Sometimes the code we end up with is way different than what we had in mind when we started, so it might not be as clean or organized as we'd like, and it might not be written in a way that can be understood and maintained later by us or by other developers. This might not sound like a significant problem, but it comes up so often that programmers have a name for code like this. We call it spaghetti code because it's all tangled up and messy like a big bowl of spaghetti. And there's another common coding experience related to this. Eventually, every programmer looks at a piece of code they wrote months earlier and has no idea how it works or even what it's supposed to do. Rather than leaving our code messy and difficult to understand, we want to revisit our work and improve it. That process is called refactoring. Refactoring is the practice of rewriting code without changing its behavior. Let's look at an example. This code asks the user to enter 3 numbers, then calculates and displays the average. It works just fine, but it could be improved. It has a lot of repetition, which means that if we want to change something, like the prompt, we have to change it in multiple places. And if we want to expand it to handle more numbers, we have to add more code. We'd end up adding another prompt and then rating 4, and then another prompt and rating 5, and so on. In coding speak, we'd say that this code is not extensible, meaning it's not easy to expand or modify. To improve it, we could refactor this code to use a loop to handle the input and sum calculation. You can see immediately that this version is shorter and doesn't have any repetition of code. And since we added a constant or variable for the number of inputs, then set our loop to run that many times, we can change the number of inputs just by changing that one value. The key here is that the refactored code does exactly the same thing as the original code, it just does it in a way that's cleaner, easier to read, and easier to modify in the future. In short, it's just a better version of the same code. There are a handful of different reasons to refactor code. We can improve readability. Clean, well-organized code is easier to understand and maintain. We can improve organization. Refactoring can help structure code in a more logical way. We can enhance maintainability. Refactored code is easier to modify and extend in the future. It's more extensible. We can optimize performance. Sometimes refactoring can lead to more efficient code. As beginners, we often don't worry much about that, but in a production environment, that can be really important. And we can reduce complexity. Simpler code is just easier to work with. What we actually do to our code when we refactor it will depend on the specific situation, but there are some common techniques that programmers use when refactoring. If you have a block of code that does a specific task, you can extract it into its own method. This makes the code more modular and easier to read. Giving variables, functions, and methods meaningful names can greatly improve code readability. Most IDEs have a rename feature that makes this one easy, so there's no reason to have a variable named x or temp. Complex if statements and Boolean logic can often be simplified or broken down into smaller, more manageable pieces. If you have code that's repeated in multiple places, consider removing the redundancy by using loops or a method or function. Sometimes using a list, array, or dictionary can simplify code that deals with multiple related values. And you'll learn a lot more about data structures as you get more experienced. Refactoring doesn't always have an impact on the way your program runs, so it can seem like a waste of time. But in the long run, it pays off by making your code easier to work with, understand, and maintain. And it's going to be expected of you as a professional developer.